Chem 1. Now for the second part of our chemical reactions videos, focusing on just the single replacement reactions. Remember from the last video, there are 4 main types of chemical reactions. There's the synthesis, decomposition, both were covered in the last video, and then there's a single replacement and the double replacement. Again, this all should have a degree of familiarity. You guys all did the POGL last week, focusing on the types. This time around, we're going to focus on how to know whether a reaction is going to take place or not. So first things first, a single replacement reaction is one where you have like replaces like. So essentially you have a reaction between an element and a compound, an element and a compound. If the element is a metal, it's going to replace the metal or the cation. If it's the element by itself is a non-metal, it's going to replace the non-metal or the anion. So for instance, the A is going to replace the B, or the A might replace the C based on what it is. So you have a reaction between an element and a compound, and you're going to make an element and a compound. Essentially, if A is a metal, it's going to come in, it's going to kick out the B, make B go by itself, and then the A is going to combine up with the C. Or if the element by itself is a non-metal, it's going to come in and kick out the C, making the C be by itself, and the A is going to take the place. So you have a single replacement or single displacement reaction. Let's look at how this works, how to write imbalance equations. So first off, you write imbalance equation. You start by just saying we have zinc reacting with copper 2 chloride. You write both of the reactants, zinc and copper 2 chloride. Then you need to figure out what the products are going to be. Now, since zinc is a metal, it's going to replace the metal, the copper. Since zinc is a metal, it's going to replace the copper, which is the metal. So the zinc kicks in, kicks the copper out by itself, and then you're going to have zinc paired up with the chlorine. Zinc is going to pair up with the chlorine, but since zinc is a +2 and chlorine is a -1, we have to worry about our crisscross. So zinc and chlorine, so zinc 2 chloride, zinc with a +2, chlorine with a -1, and then copper's by itself, it just gets a 0 charge. If the element that was by itself happened to be one of these guys, Brinkelhoff, then you would have to have that element suddenly be diatomic. Don't forget, the cation is always listed first when writing a formula, but we did that before. Okay, so how do we know whether a reaction is going to take place? Because not every single replacement reaction is going to happen. What's going to be used is what's called the activity series. And on OneNote, I'm going to provide a copy of our activity series and our solubility rules so that you can use that as a guideline. But the activity series is a listing of all the elements, or a healthy chunk of the metals, in order of how active or reactive they are. So for instance, ones that are very, very active, like the alkali metals, those would be at the top of the series. And those that are very, very non-active, like copper and gold and silver, those guys are not very reactive. Those would be at the bottom. And basically, scientists have reacted metals with other ions to figure out what was which ones were more active than the others. There's a video on OneNote that kind of shows how that was done, and we would have done a lab like that if we would have been in class. So, how does this work? Well, this is a version of the activity series. Notice potassium at the top, sodium, lithium, calcium, so on and so forth, and at the bottom is copper, mercury, silver, and gold. And they are all vary. So calcium is more active than aluminum. Iron is more active than tin. This means that they would be more likely to react. So how do we use this? Well, let's look at a couple of reactions. For instance, the first one would be iron reacting with copper sulfate, and it's going to make copper and iron sulfate. And you notice this is not balanced. We're going to focus on balancing after we get through the reaction types and focus on whether or not the reaction is actually going to occur or not. But iron is higher on the activity series than copper. So the metal that's by itself is higher on the activity series, is more active, is more reactive than the element that is in the compound. So if that's the case, where the metal that's by itself is more active, they're going to switch places. And vice versa. If the metal that's by itself is not higher in the activity series, nothing's going to happen. So we're going to notice trends. Will allow us to predict certain chemical reactions are going to take place just using the activity series. The higher towards the top, the more reactive it's going to be. So let's check out these. Iron with copper sulfate, we already said, because iron is higher on the activity series. Because iron is above copper on the activity series, yes, the reaction is going to happen, and you're going to switch the cation and the metal and swap them out and make copper and iron sulfate. Let's try this one, nickel and sodium fluoride. Well, because nickel is below sodium on the activity series, nickel is below, much further below than the sodium. Sodium is very, very active. This reaction is not going to happen. Again, if the metal that's by itself is higher on the activity series, then the reaction is going to happen and you swap the cations. But in this situation, the metal that's by itself is below the sodium, below the metal that's in the compound, so nothing's going to happen. Let's look at lithium and zinc carbonate. Well, because lithium is higher on the activity series than zinc, then yes, this reaction is going to happen. So we swap the lithium with the zinc, and we get zinc by itself and lithium carbonate. Again, worry about the charges. Lithium is going to be a +1, carbonate is a -2, so the compound is Li2CO3. Finally, aluminum and copper. Aluminum and copper. Aluminum and copper. Aluminum is higher on the activity series than the copper, so we're going to switch the two parts, and we're going to have copper by itself, and aluminum is going to pair up with the chlorine. Aluminum being a +3, chloride being a -1, it has to be AlCl3. So with the metals, we know the ranking from top to bottom. What about nonmetals? Okay. Before that, we'll notice there's one nonmetal on here, hydrogen, and that's really the focus on how water or acid would react, because it's in the middle, and the ones that are above the reaction, those metals will react with acid, where the ones at the bottom, those will not. So zinc with hydrochloric acid, zinc is higher than the activity series, so it's going to react. Copper with water, see, water has hydrogen in it. Copper is below, so no reaction is going to take place there. Calcium and acid, see, calcium is above, so that reaction is going to happen. And notice when hydrogen went off by itself, you've got hydrogen with H2 because of Brinkelhoff. And then finally, when it's reacted with water, sodium is way up here. Sodium, whenever any metal reacts with water, not necessarily an acid, but with water, you're going to make the hydrogen and a metal hydroxide. That's because your hydrogen is splitting up with the hydroxide in the water. Okay, so again, determining whether a reaction is going to take place. If the metal is higher than the hydrogen, it's going to react. If the metal is not higher than the hydrogen, it's not going to react. Well, all metals have specific place in the activity series, and we just gave a small listing, and we're going to sometimes expand that. The one that I'm going to give you as a document online and OneNote has a few more than what was on that little bar on the side there. But metals near the top of the activity series are more reactive, and because their valence electrons are really, really loose, that goes back to when we're talking about the ionization energy. They have a much lower ionization energy. Those electrons are easy to pop off. And then we test, on tests and exams, the activity series may appear, and you must remember that potassium or the alkali metals are at the top, and silver and gold are at the bottom. So what about nonmetals? Well, here's a mini list of the nonmetals. You'll notice fluorine, chlorine, bromine, and iodine are the ones that we're going to focus on, just the halogens. And these are actually in order of the periodic table. Fluorine's on top of chlorine, chlorine's on top of bromine, bromine's on top of iodine. So the periodic table shows you the activity series for the halogens. Same logic takes place if the metal, if the element on top by itself is above the one on the bottom, then a reaction is going to take place. So let's look at an example. Okay, so iodine is down here, chlorine is up there, so iodine is below chlorine on the activity series. Iodine is below chlorine on the activity series, so that means no reaction is going to take place. But fluorine is above the bromine. Fluorine is above the bromine. That means this reaction is going to take place. Bromine gets kicked out, becomes Br2, and the sodium now pairs up with the fluorine. And just out of habit, I balanced that one. So what's going to happen in the next video? This was a pretty short one. It was less than 12 minutes. Next video, we're going to focus on double replacement reactions and how to use the solubility rules. Hopefully everybody's being safe and healthy, practicing your social distancing. I'll see you in the next video.